Hello friends, how are you? In this video, we will discuss about the concept learning. Okay, so our objective is to discuss what is learning, what is concept learning, what is hypothesis spell, general and specific hypothesis, inductive learning hypothesis, Fidesz algorithm, version space, and candidate elimination algorithm with examples. So let's see one by one. So first of all, what is learning? So identification of general function from training data. So what is learning? Suppose we have a data set. We can say we have a set of data. Okay, we have a set of data, and in learning process we want to identify the general function. We want to identify the general function to using this fx, using this general function, we can capture the characteristics of the data. Okay, now we can see we have a data, say 4 data are there. So from that 4 data, we can identify a function. We may identify a general function. Say this is our general function. Say this is what our fx. So we can identify this general function fx with the help of learning. Okay. Next we can see concept learning. Now problem of searching a hypothesis that best fits the training data is called the concept learning. Suppose one training data is there. Okay, so for that particular training data, we can identify more than one hypothesis, or more than one. We can identify more than one general function. Okay, now it may be H1, H2, H3, H4 to Hm. So our objective is to identify the best one. So using concept learning, we can identify the best one. Okay, now we can see we have a training data. Okay, and we may apply some learning techniques, and from that learning techniques we can produce some hypothesis, or it is also called general concepts, or you can say it is categories. Okay, so the objective of learning is to automatically inferring the general function of some concepts. Next we'll discuss about hypothesis and hypothesis space. Now we can say hypothesis space. So suppose we have a data set. Okay, now say this is what our negative data set. Okay, and these are say positive data sets. Now we may apply, or we may identify a line that divides these two particular class separately properly. Now we may apply this particular line to separate these two class. We may use this particular line, or you may use this particular line. Okay, so we can, for the training data set, we may identify more than one hypothesis, more than one general function. So here H1, H2 to Hk, k number of hypotheses are there. Okay, and Hi is belongs to capital H, I varies from 1 to k. This capital H is nothing but the hypothesis space. It is hypothesis space. So what is hypothesis space? Set of all the hypotheses. Set of all the hypotheses is called the hypothesis space. So in this particular lecture, our main objective is to identify the best hypothesis. Okay. Now, this is what our one data set is there. So I have taken it from the Tom Mitchell book, one of the best book for machine learning. So here, serial four data are there, and the attributes are sky, air temperature, humidity, wind, water, and forecast. So these are what the attribute, or these are called the features. And here the class level is what? Enjoy sports. So this is nothing but our training data. This is nothing but our training data, or you can say it is a historical data. It's old data. And inside the data, there are two parts, X part and CX part. The X parts is the data, or you can say the attribute, the data with the sixth attribute. and CX part is the class level. So this is what our class level, that is what our CX. So yes means enjoy sport, yes means it is a positive example as you, and no means it is a negative example. Okay, now say if the sky is sunny, air temperature is warm, humidity is normal, wind is strong, water is warm, forecast is same, then the person enjoyed his sports. Similarly, in another instance, sky is sunny, air temperature is warm, humidity is high, wind is strong, water is warm, forecast is same, he or she enjoyed the sports. But if the case is like that, so in these three cases, that person enjoyed the sports very much. But in the third case, if the sky is rainy, air temperature is cold, humidity is high, wind is strong, water is warm, forecast is changed, definitely he or she will not enjoy the sports. Or the person didn't enjoy the sports because it's a training data, it's old data. Okay, so we will use this particular data set which I have taken from the Tom Mitchell book. Okay, so the task is to learn to predict the value of enjoy sports for an arbitrary day based on the value of its other attribute. So our objective is what? We have a training data. We have to identify a function. We have to identify a general function or hypothesis through which we can identify whether we will provide the attribute, and from that attribute we will identify whether the person will enjoy the sports or not. We have to predict this one. So we need to identify the best hypothesis. We need to identify the best hypothesis through which we can predict whether the person will enjoy the sports or not. Okay, now to represent the hypothesis, we may use this particular form. Say representing of the hypothesis in this case, for yes, for positive example, we may use this one. Say sunny, warm, question mark, strong, question mark, question mark. Here in this particular hypothesis, 6 attributes are there, 1, 2, 3, 4, 5, 6. Since in our training data sets, 6 data are there, 6 attributes are there. So in a training data set, if 6 attributes are there, then in a hypothesis also there must be that particular number of attribute. Now we can see here in hypothesis we will use some notation. So if we use question mark, that means what? It is accepted for all value, or any value is accepted. If it is a phi, that means what? It will not accept any attribute. Always it will give the negative answer. Always it will give the positive answer. Or sometimes we may use the value, say x. So that means what? This attribute or x is accepted. So if it is a sunny, that means sunny word is accepted. Sunny variable is accepted. Okay. So if in any hypothesis, if all the question marks are there, that means that particular hypothesis is accepted for any value. It is general acceptation. But if any attribute, if any function, hypothesis, all are phi, that means it will never accept anyone. It will never give any positive value. Every time it will give the negative answer. Okay. So little bit recap. So we have a training data. We may apply concept learning. From that concept learning, we can identify the best hypothesis. Okay. So this is what? Training the hypothesis, training the machine. After that, after identification of the hypothesis, we can use that particular hypothesis to identify whether the person will enjoy the sports or not, yes or no, for any new arbitrary day. Okay, so that is the task of the hypothesis, that is the application of the hypothesis. So first of all, we have to identify the hypothesis and then we can use that particular hypothesis. Okay, so already have discussed there are two types, two general type, most general hypothesis and most specific hypothesis. Most general means what? So here 1, 2, 3, 4, 5, 6, 6 questions marks are there. That means what? It is a most general hypothesis. Every time, whatever will be the value, always it will give positive answer. And it is a most specific hypothesis. In this case, we use the phi. This phi indicates that always it will not accept any value and always it will give the negative answer. Okay. Next, inductive learning. So in inductive learning, we can see here we have a training data. We may use inductive learning algorithm to generate the best hypothesis. The question is, what do you mean by the best hypothesis? That we have to identify. So every time our objective is to identify the best hypothesis, fx. So what is the best hypothesis? That we have to identify. So using the hypothesis, the class level of any unseen data are identified properly or approximate the target function will over other unobserved examples. I am repeating the line. Using the hypothesis, the class level of any unseen data are identified properly or approximate the target function well over other unobserved example. So that means what we can see here. See, this is what our say two hypotheses are there. Say hypothesis say 1, hypothesis 2 and hypothesis 3. Now we have a training data set or we have a test data set. So the test data set, the performance of the hypothesis will measure. We can measure the performance of the hypothesis and the error rate. The error rate we can identify the best one. Okay. Now, what do you mean by more general, okay, or more specific hypothesis? We can see here we have a three data, say three TS data, say where the attributes are sky, air temperature, humidity, wind, water, forecast, and our objective is to identify whether in that particular day the person will enjoy the sports or not. Let we have a two hypotheses. H1 is what? Sunny, question mark, strong, question mark, question mark. Another hypothesis H2, sunny, question mark, question mark, question mark, question mark, question mark. Now, if we use, say, H1, if you use H1, that means what? If it is a, you can see just say 1, 2, 3, 4. 1 and 4 attribute. Say 1, 2, 3, 4. So sunny and strong. Sunny and strong is there. Both are there. Yes, it is there. So definitely, always it will be the answer is yes. Third case, sunny and strong is there. No, only sun is there. Here it is weak. So if we use H1, it will give the answer no. In the third case, sunny and weak. So sunny and strong is there. So it will satisfy both the attribute, but here it is satisfying only the first attribute. It is not satisfying this particular strong. So that's why here should be the no. But if we use the second hypothesis, this one, so we have to see only the first attribute. Okay, so in a first attribute we can see, so if it is a sunny, we just, so that means what, for hypothesis H2 we have to see only these particular values. So it is a sunny, yes, so write it yes. If it is a sunny, yes, put yes. If it is a sunny, yes, it's a yes. So that means we can see here H2 is more general than or equal to H1. That means this particular H2 function, H2 hypothesis generates more yes than H1. Or in the reverse, you can say H1 is more specific than or equal to H2. So that means we can say, crudely we can say, in any hypothesis, if more number of question marks are there, that means that hypothesis is more general. Or less number of question marks are there, that means the hypothesis is more specific. So we can see here, so H1, H2, H3, H4, that 4 hypotheses are there. So we can check the attribute 1, 2, 3, 4, the fourth one. Here 1, 1, 2, 3, 4, fifth one, 1, 2, 3, 4, and 5. We can check here 1, 2, 3, 4, 5, 6. Okay. So similarly 1, 2, 3, 4, 5, and 6. Now if you use H1, then what will be the output of X1? So for the X1, we have to check sunny and strong, sunny and strong. So both are true. So X1 will be what? Yes. What about the X2? Sunny and light is there. So it is not true for X2. The answer will be no. We can say H2. So we have to just select only one attribute, that is sunny. Both the case it is sunny. So we can say for both X1 and X2 it is yes. Now you can see the H3. We can check first and fifth. So first is sunny, fifth is cool. So that means it is okay for ES1, and sunny with warm. So it is not okay. So X2 we can say it is a no. We can check the fourth one, H4, sunny, warm, strong, cool. Sunny, warm, strong, cool. Okay, so that means what? For H4, X1 is okay, yes. Sunny, warm, light, and warm is there. That means for this particular H4, that X2 is no. So we can say H2 is, that means say this one is the more general. Okay, and but here the remaining hypotheses are giving different answer. Next, we'll discuss about the FindS algorithm, or finding a maximally specific hypothesis. Now, using FindS algorithm, we can identify more general hypotheses iteratively. So the objective of the FindS algorithm is what? Identify the more general hypothesis. And here we move from specific hypothesis to general hypothesis iteratively. Okay, that means what? We start our algorithm with specific hypothesis, then move towards the more general hypothesis. So first of all, you just see the FindS algorithm. Now here input is the training data with the class level, output is hypothesis. Now initialize age hypothesis to the most specific hypothesis in age, capital H, and age contains all the 5. That means H is the most specific. Okay. Now for each positive training data, remember one thing, in FindS algorithm, always we consider the positive example. So for each attribute AI in age, if AI is satisfied or same, then continue or do nothing. Else replace AI in age by the next more general constraint. Okay. And finally, return the hypothesis age. So just see the example, FindS algorithm. Now we can see the FindS algorithm. So 4 data are there, 4 column rows are there, say, and the 6 attributes are there: sky, air temperature, humidity, wind, water, forecast, and this is what our class level. And definitely I have already told you that I have taken it from the Tom Mitchell book. So here 6 attributes are there, okay, and one class level. So you have to always start with the specific hypothesis, that is phi h0. You can say it is h0. So all are phi, that is the most specific. So first of all, we just see the first attribute for each positive. So first is positive, yes. So already you know yes is positive, we assume, and no means negative. So if h0 is equal to phi, it's the initialization. So first at the for the first data, we just replaced all the attributes, all the values with the phi. So first one is what? Sunny, then warm, then normal, then strong, then warm, and same. Okay, second iteration, for the second data, we compare this with the first. Both are same, keep the value. Warm with warm, this one. Both are same, keep the same. High and normal. Now these are different. So if it is a different, then apply, we can see here. So if it is a different, then we have to apply the next more general constraint. So for more general constraint, we use the question mark. And if it is satisfied, if it is the same, then we have to continue the process. That means keep as it is. Are you getting this one? So here high is there, but here in H1 it is warm is there. It's a different. So we use the more general part, that is what? Sorry, here you can say high, it's a normal. Both a different thing. So instead, so here you use more general notation, that is question mark. Then strong, both are same thing, do nothing, keep as it is. Warm, keep as it is, same thing, same, keep as it is. The third one is the negative example. So we have to ignore it. So we just ignore this one. Go for the next. Now check once again. We can see. So we can see here. Here right now, we are in this particular position. H0 is the phi, more specific. Then for the first data, copy the same thing. For the second data, H2, so it is sunny, warm, question mark, strong, warm, same. Sunny, warm, question mark, strong, warm, same. H3 is the no. So for that, that's why it is H2 is nothing but our H3. For H3, we use the H2 because it's a negative one. Now for the H4, once again we have to compare. Here it is sunny and sunny. Do nothing, keep as it is. Warm and warm. Do nothing, keep as it is. High and question mark. So we have to follow, we have to copy the question mark. We have to continue the question mark. Now in any hypothesis, if any attribute is converted into question mark, then we have to continue, we have to follow the, we have to continue the same notations. Next it is a strong and strong, keep as it is. Here it is a cool and warm. Now it's a different. So use the most general notation, that is question mark. Change and same. So change and same, it's a different. We have to use question mark. Now end of this particular data. Now definitely this is what our final answer. So the hypothesis is sunny, warm, question mark, strong, question mark, question mark. Now after that, we will use this particular hypothesis to identify for the unknown data. So notes on hypothesis, definitely it ignores the negative example and it is very much sensitive to the outlier data. Okay, so outlier data means what? Suppose here the instead of yes, if it is a no, okay, so that means what? It's outlier data. Okay, or instead of warm, it is something different. Now, so it is a positive, yes. Now instead of sunny, it may be say rainy, and it's a say it's a wrong. It's the outlier. then definitely output will be what? Different. So it's very sensitive to the outlier. Now, hypothesis spaces are described by conjunction of attributes constraint. So definitely conjunction attribute, say sunny, okay, warm, and so on. That means what, we have to check the attributes to give the result. Now, beginning with the most specific hypothesis in H, then generalize the hypothesis each time it fails to cover an observed positive training data. So definitely it will start with the most specific, then we move towards the most general hypothesis, and it identify only one hypothesis from H. So H is what? It's a hypothesis space. So from that hypothesis space, find this algorithm identifies only one hypothesis. Okay, we can see one example. Suppose we have a training data, say 5 data are there, and here the attributes are big. Okay, so one bird is there. Suppose assume it's a bird. Okay, so this is nothing but our beak. Fly, whether it can fly or not, or underwater swim, whether the bird can swim underwater or not. Now if it's a pigeon, it has beak, it can fly, but it cannot swim underwater. If it's a duck, it has beak, it can fly, it also can swim underwater. If it's a bat, it don't have the beak, it can fly, but it cannot swim underwater. If it's a kiwi and a bird, it has a beak, it cannot fly, it cannot swim underwater. And if it's a cat, it don't have beak, it cannot fly, cannot sleep. So bird, so this is what our class level, this is what our class level. So we can see here, so this is if the attribute is this, the class level is yes, that is positive, here it is positive. So is it a bird? Pigeon is bird, yes. Duck is bird, yes. Bat is bird, no. Kiwi is a bird, yes. Cat is a bird, no. So it's a bird. If it is yes, then it's a positive example, and if it is a no, it's a negative example. So first hypothesis is what? It's so here three attributes are there, 1, 2, 3. That's why we need 3 columns. So starting with the most hypothesis, the first data is what? Yes, yes, no. So it is yes, yes, no. We have to copy the same thing. Second positive example is there. Yes, yes, yes. Yes, yes, yes. Match. Don't keep as it is. Yes, yes. Keep as it is. Yes and no. Convert it into the most general notation, that is question mark. Okay. Are you getting this one? So we can see here. 1 second we can see. Okay. So the start. So the most specific hypothesis is what? It is H0. So first positive example, copy the same. Yes, yes, no. Copy. Yes, yes, no. Second positive example, just compare. Yes, yes, both are same. Continue, keep as it is. Yes, yes, keep as it is. Continue. Yes and no. Now it's a different. Use the most general notation. Third one is the no. We have to ignore it. Fourth one is, it is yes. Compare once again. Yes, yes. So keep as it is. No, yes. Now it's a different. Definitely use most general connotation question mark. No question mark. Definitely if once it is a question mark, we have to continue this one. And finally it is a negative data, so we have to ignore it. So the final hypothesis is what? So the final hypothesis is yes, question mark, question mark. Okay. So any unknown data is there. Say it is no, yes, yes. Question is whether it is a bird or not. So we have to check only the first attribute. Now it is no, it is yes. Definitely you can say it is a no. Now that means it is not a bird. Similarly, if it is a yes, yes, no. So we have to check the first. Both are same. We can say it's a bird. Okay. Now we can see next we can see the Python implementation of the find this algorithm. Okay. Now this is what our Python implementation of the find this algorithm. Here we import the NumPy as MP, and this is what the training data set. I have taken it from the Tom Mitchell book. So sunny, warm, normal, strong, warm, same. These are the attributes. Yes, yes, no. These are the class levels. Here it returns the number of rows and columns. Okay. Here we print it number of rows and columns. Here we need the MTS array where we put the 5. Okay, to define the most specific hypothesis. This is nothing but the general initialization part. First column, if it is a first data, we store the here we store the first value. Okay, so if it's a first values from the first data into the specific, and from the second data till the r means total data. If it is a no, then we have to ignore it because it is a negative example. If it is a no, we have to ignore it. But if it otherwise, we have to check each and every attribute. And if it doesn't matches with the specific hypothesis, then you have to put question mark. And if it is matches with, definitely it will continue. Don't do anything. You have to keep as it is. That is the logic. Okay. So we can see here. So this is what our main logic. So this part is the initialization part. Okay. Here we put the first data. We have to just copy the as it is. We just copy as it is. And here, if the negative example is there, we have to ignore it. Otherwise, we have to check each and every attribute. If attribute doesn't match, then we have to put the most general symbol, and finally we have to print it. And we can see the exam out. We can execute it. So we can execute it. The number of rows and columns are 4 and 6. That this is the data set. Okay, this is what our most specific hypothesis. Okay, and here we should it's the most because here we entered the 5, and the final hypothesis is this one: sunny, warm, strong, and question mark, question mark. Okay, so you can easily write it, you can execute it. Okay, now if you put some value, more value, we can get different result. Okay, just put some more value here. Say it is a yes, and here put it. Instead of sunny, let it is a rainy. Okay, and execute it. So we will see this part will be now the question mark. Okay, now execute it. Now you can see the first one is now the question mark. The output will be different because this one is the rainy part. Okay, so here we can check every time, we can check the present hypothesis value. Okay, so we can see, we can copy it, and we can, if you paste somewhere here. Okay, so we can see the difference. We can see the all the hypotheses. We can see. So instead of final hypothesis, if you write the intermediate, and you can execute it. So you can say most specific. First one, this one is the first one. This is the second one. This is the third one, and this is the final one. Okay. Next, we'll discuss about version space and candidate elimination algorithm. Okay. So what is that? Now, candidate elimination algorithm produces set of all hypotheses consistent with the training example. So what is a consistent hypothesis? A hypothesis is consistent with the training example if it correctly classifies the data. If that particular hypothesis correctly classifies the data, that we can say it's a consistent. So say already you know the version space. So what is version space? The candidate elimination algorithm represents the set of all hypotheses consistent with the observed training example. So candidate elimination algorithm produces all the hypotheses. It is not like Findess algorithm. In Findess algorithm, we can identify only one hypothesis. But using candidate elimination algorithm, we can identify all the hypotheses. This subset of all hypotheses is called the version space with respect to the hypothesis space H and the training example D, because it contains all the probable version of the target concept. So we have a training data, we apply candidate elimination algorithm. Now this particular algorithm identify all the hypotheses H1, H2 to Hk. So that is nothing but our version space, or list of hypotheses is called the version space H. And small hi belongs to capital H and I varies from 1 to k. So total k number of hypotheses are there. Okay, so we can see one simple example. Now here we can see, now once again we just use the Tom Mitchell data. Here 4 data are there, and here the attributes are sky, air temperature, humidity, wind, water, forecast. So 6 attributes are there, 1 class level. Okay, so the version space is represented by its most general and least general function members. So this is what our, we can say this is what our most general hypothesis. Okay, we will see how to identify this. Just for this particular, for the sake of completion of this particular version space, we just see here the version space is represented by its most general and least general member. So this is what our least general or most specific. These members form general and specific boundary sets. So this is what our most specific, this is what our most general. So these two are the boundaries that determine the version space within that partially ordered hypothesis space. So this is nothing but our version space. So using candidate elimination algorithm, we identify the most specific hypothesis and most general hypothesis. From the most specific and most general, we can identify the other hypothesis. And the whole set is called the version space. Okay, so given only those two sets S and G, this is what our S and this is what our G, it is possible to enumerate all members of the version space as needed by generating the hypotheses that lie between these two sets. So this is a specific set, this is a general set. We can identify the other sets, and the whole collection is called the version space. So the version space is precisely the set of hypotheses contained in G plus those contents in S plus those that lie between G and S in the partially ordered hypothesis space. That means what? We have an S more specific, we have a G. These two are the boundaries. In between, the partial order hypotheses are also there. That is called version space. Next, we see the candidate elimination algorithm. Okay, so what is that candidate elimination? Now, candidate elimination algorithm computes the version space containing all hypotheses from H that are consist with an observed sequence of the training example. So already we know we have a most specific, we have a most general, and in between that we have to identify the other hypothesis. Now consider for all the data both positive and negative, but goal is to form hypothesis for the positive only. Remember this one. So in find S, in fine days, we consider only the positive training data. But in candidate elimination algorithm, we consider both positive as well as negative. And form the hypothesis only for the positive data only. So we can see the example. Okay. Now we can see we have a 6 attribute: sky, air temperature, humidity, wind, water, and forecast. So if it is a positive, we have to move in this direction, and if it is a negative, we have to move the up direction. Okay. Now initialization, most specific, all are 5. So 1, 2, 3, 4, 5, 6. 6 5 are there. It's the most specific. And most general, all are question mark. 1, 2, 3, 4, 5, 6 attributes are there, because here in this particular table 6 attributes are there. 1, 2, 3, 4, 5, 6, and one class level is there, that is enjoy sports. This is what our class level. Okay, so first one is the positive data. We just copy as it is: sunny, warm, normal, strong. Sunny, warm, normal, strong. Warm, same, keep as it is. So G1, keep G1 as it is, don't do anything. You just take the second data. Now compare sunny with this sunny, both are same thing. Sunny with this sunny, keep as sunny. Warm with warm, keep warm. High with normal, now it's a different, use the question mark. That means use the more general symbol. Next, strong and strong, keep as it is, strong. Warm, same, keep as it is, warm. Same, keep as it is. Same and same, keep as it is, same. So this is what our S2. Since it is a positive, then keep as it is, G2. Next, it is a no. You just see properly. Here it is no is there. Then don't do anything. Then don't do this particular part, S part. You just see the G part. Okay. Now, remember one thing. Every time we form the hypothesis for the positive. Okay. So here it is no is there. Now, if it is a no, then what to do? So if it is a no, we have to see this one. After that, first time. So we just check one by one. So it's a rainy, and here we can say for S2 it's a sunny. So both are different values are there. So you have to copy from the specific hypothesis, sunny, and remaining are the question mark, because it is just general. We can say just above the general. Okay, so here it is most specific, this one is the most general. So we can say this attribute, these hypotheses are more specific than this hypothesis. So here in this particular part, we just include only one attribute. We consider only one attribute only. Next is what? Cold. So cold is there, compare with this warm. Both are different thing. Copy from that attribute warm. So question mark warm, question mark, question mark, question mark, question mark. So it's a second attribute. That's why we keep the first attribute question mark, second attribute warm. Next is question mark, and it's a high. So remember one thing, if question mark is there, we can ignore the hypothesis for the G. Next is strong. Both are same. Here it is strong, here also it is a strong. If both are same, we can ignore the hypothesis. So if both are different, then copy from the hypothesis, specific hypothesis. Here it is sunny and warm, rainy, cold. Copy from the sunny and warm. Okay, but if it is a question mark is there, we can ignore it. If both are same, we can ignore it. Here it is warm, and warm. Both are same. We can ignore it. Now here it is a change and same is there. So same is, these are different. We have to copy from the hypothesis spin. Same. Okay. So after third data, our condition is what? We are in S2 and we have the G3. So in G3 part, only one attribute value is there. The remaining are the question mark. Next, the fourth one. Now, remember one thing, in candidate elimination algorithm, we have to eliminate the hypothesis if it is not satisfied the positive one. Because all the hypotheses are for the yes, for the positive class. Now, just check one by one. Sunny. Sunny is there here. Okay, here Sunny is there. In S2, Sunny is there. Both are same thing. Keep Sunny. You just take another color. Say this one. So if it is a Sunny, keep it a Sunny one. And here it's here also in G3 also Sunny is there. So all three are for positive. Next is warm is there. Here also warm is there. Here is also warm is there. Keep the warm. Okay. Here also warm is there. Keep this one. There is no confusion. There is no ambiguity. Next it's a high and it's a question mark. So definitely we have to write question mark. Next is a strong. Here also strong. You have to copy the strong. And there is no attribute related to strong. Now it's a cool and it's a warm. Both are different. We have to use question mark. Here it is a change and here it is the same. So both are different. So in that case we have to apply question mark. So here we have a attribute with same is there, but same is not accessible, and because for the hypothesis the last attribute should be the question mark. Here the last attribute we have used the same, so it is satisfied. It's the last attribute question mark, it's okay, but here it is the same. So we have to eliminate this after fourth data because the ambiguity will create. Okay, so change is there, here it is the same. So both are different thing. We have to use the question mark, but here same is there. It should be the question mark. So if any hypothesis all the question marks are there, we can eliminate it. Now next we don't have any data. So we can see after getting the S and G, we have to enumerate the other hypothesis. So we have a S4 and we have a G. So that means what? This one and this one, we have to eliminate this one. So this is what after fourth data and this is what after fourth data. So this one is this one, this one is this one, and we have to eliminate this one. Now we have to enumerate the things. So to enumerate the things, what we can do, we can identify the combination of the attributes. So sunny with, we can say sunny with warm. So in this case only single attribute is there. Here we have to identify the hypothesis with two attribute values. So we can identify sunny with warm. Okay, this one. Sunny with strong, this one, and warm with strong, this one. So this is what our version space. So here how many attributes are hypotheses are there? 1, 2, 3, 4, 5 and 6. So 6 hypotheses are there. So candidate elimination algorithm identify the sixth attributes, 6 hypotheses. Are you getting this one? So we have a after considering all the data, we have two boundaries. We have two hypotheses, most specific and most general. So this one is the most specific This one is the most general. So from this boundary, we have to enumerate the other hypothesis. So here single attribute is there. So just above that, we have to identify the hypothesis which are more specific than G4. So here we consider the two attributes. So sunny, we have to identify the combination of that. So sunny with warm, sunny with strong. So sunny with warm, sunny with strong, and warm with strong. Okay, warm with strong. That is this one. Okay, so we can see the Python implementation. Remember one thing, here only 4 data are there. So as further training data is encountered, the S and G boundaries will more closer to each other and reduces the size of the version space. Okay. Now we can see one simple example. So use of that hypothesis. Say already we know we have the 6 hypotheses. We have identified the 6 hypotheses. 1, 2, 3, 4, 5, 6. Okay, so we have a 6 hypothesis. Now we have a test data. This is what our test data. Okay, so hypothesis number 1, 1, 2, fourth one. We have to check 1, 2, fourth. In hypothesis 2, we have to check 1, fourth. In third, we have to check 1, 2. In fourth, we have to check 2 and 4. In fifth, we have to check first one. And in sixth, we have to check the second one. So for this one, we can say if we apply this sunny, warm, strong, 1, 2, 4. So 1, 2, 4. Sunny, warm, strong. For the first data, it is okay. Yes. Then we can say rainy. Okay, rainy, warm. So anyone is not correct. So we should not take the 2. The 2 part will not take. Okay. Next, sunny, warm, and strong. So sunny, warm, and light. The fourth one is light. So this one is not satisfied. Okay. Next, sunny, cold. Cold is this one is not satisfied. So only first one. So S4 satisfy only the first data. We can say the second, sunny and strong. First and fourth. First and fourth. Sunny and strong. First one is yes. Rainy. Second one is not yes. Sunny and strong. Third one is not okay. Sunny and strong. It is okay. So fourth one is yes. Sunny and warm. Sunny and warm. First one is yes. Rainy and cold. Second one is not okay. Sunny and warm. Second one is yes. Sunny and cold. Cold one is not correct because it is warm is there. So we should not consider the fourth one. Warm and strong. 2 and 4. Warm and strong. First one is yes. Okay. Cold, not second one is not yes. Warm and light. Light one is not yes. Cold, second one is not yes. Sunny. Sunny, rainy, sunny, sunny. That means what? First, third, and fourth one is yes. Warm. First and third one is okay. So first and third one is yes. So if it is a first one, if it is a first attribute, you just take another color. If it is a first, so if it is a first, all says yes. All says yes. So it's a yes class, positive class. So first one is will be the positive class. Now the second one is not rainy, cold, normal, light, warm, same. So no one is satisfied the second, only this one. Sunny and warm. No. Second one should not be satisfied because sunny and warm is there, but here it is rainy is there. So it should not consider the second one. So no one is satisfied the second one. So all says it is a negative. So definitely it will be the negative. Third one. So third one we can see. Third one we can say 3, 5, 6. We can say 3, 5, and 6. So we can say 3, 5, 6 are positive. So 3, 5, 6. So 3, this one is what? Sunny and warm. So sunny and warm, it should be third one. It should not be 2. So 3, 5, 6 for the third one. 3, 5 says it is a positive, and 1, 2, 4 says it's a negative. So it's a tie. So we need more data for classification. For the fourth data, 5 and 2 says it is a positive. 5 and 2 says it's a positive. The fourth one. Okay. 5 and 6. We can say 5 and 2. Sorry, 5 and 2. 5 and 2 says it's a positive. But remaining 1, 3, 4, 6 say it's a negative. So here 2 positive, 2 hypothesis says it's a positive, 4 hypothesis says it's a negative. So we have to take the majority voting and we consider it's a negative one. Are you getting there? So we have a test data, we have a set of hypotheses. For the each and every training data, we have to check whether these are satisfied that particular data or not for the positive class. And if all says positive, then it's okay. If all says negative, then it's okay. If both are same, then definitely we cannot say anything. We need some more data, or we can say we need some more hypothesis. Or if we may apply the majority voting to say whether this particular training data is positive class or negative class. We can say our own example here. Big fly underwater swing bird is there. So we have a data. So we initialize with the most specific and most general. So first one is what? It's a yes, 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 no. So we have to put yes, yes, and no. Next, another yes is there. Yes, yes, yes. So yes, okay, yes, and no. There is a mismatch. We have to use the question mark. Next is no is there. This one. So we have to compare with this no and yes. So no and yes is there. Definitely, we have to follow. Both are different thing. We have to take the yes part. The remaining are question mark. Next is yes, and here it is yes. Both are same thing. So we have to ignore it. Here it is a no, and it's a question mark. We have to ignore it. So if the values of the negative class of that particular attribute is the same as that particular hypothesis space, or it's a question mark, we have to ignore it. But if it's a different no and yes, you have to copy the. Next is yes is there. Yes, no, no. So yes, both are same as it is. Yes, no, and yes. It's a no and it's a yes. Different thing. Use the question mark. Question mark is there. Last one is no. So no, and we can see no and yes. Both are different thing. Keep as it is. No and remaining are question mark. So definitely we have to follow this one. So we have only the one hypothesis. This one. So if we have a training test data, we don't know the class level, then what we can check? We can check with the hypothesis yes, question mark, question mark. So if it is a yes, yes. It's a bird, yes. No, it's a yes. It's a bird, no. No, yes. It's a bird, no. Yes, it is yes. It's a bird, yes. So we can use this particular hypothesis to identify the class level of the unknown data. And you just see the Python implementation of canonical. In Python implementation, we have just identified the ACE and most ACE and G. So please do yourself the other enumeration in between the hypothesis. Here we have to import numpy as np. Okay, this is what our data set. We have to return the number of rows and columns. Here we need two arrays, empty arrays, S and G. S to store the specific hypothesis, G to store the general hypothesis. Okay, so here we load the content of the first row. Are you getting? And here we consider both yes as well as no. Okay, so if it is a yes, we have to identify this particular logic. We have to apply this particular logic. Okay, I will upload it. You can see later the logic. And if it is a no, we have to use this one. And finally, it will print all these things. Okay, so here we delete some hypothesis if it creates ambiguity. Already you know in both the cases. Okay, and we can execute it. So this is what our candidate elimination algorithm. So in GitHub I will upload it. You can check later, and we can see the output. So we can say this is what the data set, number of data 4 and 6. This is more specific hypothesis, more general hypothesis. Now intermediate specific hypothesis, here it will print the intermediate specific hypothesis, intermediate general hypothesis. We can say Sunny is there, warm is there, and same is there. After that, intermediate specific hypothesis this one, specific hypothesis this one, but here in the general hypothesis this particular hypothesis is not present. It's a that means actually it is incomplete program. After that, you have to identify the version space. You have to identify the combination of the attributes to get the version space. So please check yourself. You just download this and you just add those one. Okay, and updated algorithm, updated program. You can send the link so that others can see your program from the GitHub. Okay, are you getting this one? You just copy this particular algorithm or write your own algorithm, and here it is intermediate. Here we just here we identify the most specific and most general, the boundaries. The in between intermediate hypotheses are not there. You just write your own program to identify the intermediate hypothesis, and in the description part you put the link so that other can download it. Okay, so that is the end of this particular video. Thank you very much. Thanks a lot.